A small rubber ball is tossed upward from a height of 1.5 meter with an initial speed of 4 meter per second. It reaches a maximum height and then falls down. After bouncing once on the ground, it reaches a height of 1 meter. If the ball is in contact with the ground for 0.1 second during the bounce, what is the average acceleration of the ball during its contact with the ground? Assuming g as 10 meter per second square. It's a good question. So let me. What we have here is a ball being. A rubber ball is tossed upward from a height of 1.5. Okay. So this is 1.5 meters. It's thrown up. We don't know the initial velocity. And it reaches the ground and then it will bounce basically, right? So once it reaches the ground, it's in touch with the ground for 0.1 second and then again it rises to a height of 1 meter. So here the final velocity is 0 meter per second. So here it's thrown up. It's just not let go, it's thrown up. So we need to consider that as well. Wait. It's tossed upward for a height with the initial speed of, okay, speed is also given, my bad, 4 meter per second. So I think I have written all the information needed. So this is point of contact is 0.1 second and we have 10 meter per second square. Okay guys, so we can take down as positive if you guys want to. So that's left to you. Okay, so yeah, how do we do this? See, first thing I'll give you a clue is acceleration is change in velocity by time. So we need to figure out the acceleration at this point. So we need to figure out what is the initial velocity, what is that final velocity, and what is the time. So pretty much all the information is there on the screen with a bit of calculation, that is. Okay, let me explain. So we have, first is velocity. Sorry, this is working. We have velocity. We need to figure out velocity at point of contact. Just before contact. Just before contact. How do we figure out? So what is the velocity over here before contact? So we know the height. We know that the object has an initial velocity of 4 meter per second square because the object will go up and come down and it will have the same velocity that we have seen with all of this. Right? We have studied that. So we have the final velocity is equal to u square plus 2as. I think we can use this. So this is 16 and this is 2 into 10 into 1.5. That's it. So we know VB would be equal to 330/46 square root of 46. Square root of 46. For the sake of, I'm curious about the answer. For that sake, I'll go with the calculator and this is 6.78 meter per second, guys. Again, I'm using calculator because I'm curious about the answer. So root 46 can't be factorized. So 23 and 2, yeah. We can't do much about this. Now, then we'll figure out the velocity after bouncing. So we have final velocity we know, and we know we need to figure out u basically plus 2 into a into s. So final velocity is 0. This is u square, and this would be plus 2 into 10 into, this is 1 meter. So u is equal to, and by the way, this would be negative. Okay, I know this is u square and all of that. So we can take this as negative because it's opposite to the direction of the velocity actually. So square root of 20. Again, for the sake of curiosity, I will use a calculator. 4.47 meter per second. Okay, I need to explain the negative. Some of you might be confused with this. So for this case, for the second case, wherein we have the object in contact with the ground, so after contact, what happens? It will bounce off with a non-zero velocity. Only then it can go up. This was a diagram. So the velocity is up, our acceleration is down. So I can change it any point of time, guys. My direction of, positive and negative, I can change it depending on scenario by scenario. So I need not consider this at all for this case. So this can be two different diagrams. Okay, that can be the deal. Right? So we get negative, and on rearranging, we'll end up with this. So this is the last bit, acceleration or average acceleration. Average acceleration during contact. I think that can be the heading. So how do you figure out? So change in velocity by change in time during the time. So we have a velocity of 4.47 in the upward direction minus an initial velocity of minus 6.78. This entire thing divided by a time of 0.1. I think it's 0.1. Yeah, 0.1. That's it, guys. So we have an object that is going up. That's the final velocity's direction. Minus because the initial velocity, that is before the contact, it's downwards. So object is downwards. It's in touch with the ground, and then it moves upwards. So this is 4.47. This is final. This is initial, remember. So this is 6.78. If I consider up as positive direction, so this is positive and this will be negative, as simple as that. So acceleration will be, again, for the sake of curiosity, I'm going to use calculator. So this is 11.25 and divided by 0.1, it will give us this value. So that is a lot of acceleration. 112.5 meter per second square is your answer. Again, here the entire thing is about the direction. It is a good exercise for us to get a hang of direction. So you need to understand that it's flexible. You can go with scenario by scenario. You can take up each case and figure out what direction you want things to be positive and which direction should be negative. Okay. So yeah.